Hello, today I will show you the new application CBA Board 2. It's a geometry software and also a whiteboard application for teaching. What makes it different from something like ActivInspire is that the tools are more precise and they also contains a lot of helpers to make your construction easier and faster. So what I will do is just prove the second core theorem using this, and that way we'll go through the tools, and also I will show you the themes, because what you are seeing here is the simple theme, like the classic theme I would say, but it has other style to offer. So as a reminder, I will explain what is the theorem. You can see that when I manipulate the compass, there is a magnifier showing the tip that is selected, obviously. You can see that there is a small button near the pen tip. That's to enable or disable the pen. I want it enable, and I will do a rotation to create a circle. You can also see that if I move the tip near the circle, it snaps, which helps to place it precisely. And when we go near the edges, it ensures that the handles stay in the screen, which is a stupid feature, but important one. We can move the circle. Why not? Okay, let's create the sequence. For that, I have enabled this auto key points, and that's important because when I would create a segment, I want them to be connected to the circle. So if I take the roller and I draw something, a segment, and you see it snap to indicate that it snapped to the circle. If I release, it creates the segment. But now if I move the circle, the segment is not attached to it. So what I would do is create the point. And then now, because I created the point on the circle, they are attached to the circle. And that means I can continue, and you see that the ruler is snapping to the object, but also to the point. And the rotation, if I move the cursor near an object, it will snap. That's to make it easy. So here I want to snap to that point. And same stuff here, you see a snap that happens, so that I start on the 0. And I will just draw the line. Now, like I said, the line is attached to the point, and the point are attached to the circle. And if I move the point, they only move on the circle. Let's create the other pair. The advantage of this from GeoGebra is that you see the real tools in action, which is needed for the younger pupils, because if they see, poop, I create a circle, they don't understand you need to use a compass, so it's good to demonstrate. Now you see the pointer bound to the circle and the lines too. So the theorem states that if I multiply this length by this length, I would have the same result as if I multiply this line by this. That's what it states. And to prove that, I need to prove another theorem. And that will lead me to use the angle tool. So let's do the compass, but this time I need to know the center of the circle for the inscribed angle. I would first draw the point, and now I will draw a circle and use another radius. Okay, so now I have my circle, and you see that this point was created because to define a circle you need 2 points at least. So I move this point. What I will do here, I don't want to move this point, so I will hide and show objects, and I'm hiding that point. So now the point is invisible. So I can't move the point. In that circle, and on that circle, I will put points, and you see that the cursor changed to say that we are adding. I'm doing exactly that. And I will add a few segments to represent the angle. We have the inscribed, the interior inscribed angle. Yep. So I have this, and I would need this one. And yeah, so that would be, I need to demonstrate this. So this angle is related to this angle, and we need to discover how they are related. That's the point of the demonstration. For that, I need to complete the figure. So that means I will just close the triangle and create 2 more triangles. So let's go. Okay. No, I didn't. Up. And I will start that. Let's check that everything good. There, this angle I drew wouldn't annoy me because I need to split it. And to make my life easier, I would do the thing. Yeah, you can see that there is a blue circle around the point just to confirm that point that you will use for the angle. Okay, so I have one there. And I would say this one, okay, that this is 2 arcs, not 1 arc is good. So I will keep 1. That means I need to put an angle the other side. That is also 1. Up. Let's move this here. Here I would say 2 then. Okay, and for the last one, not the last one, I would say. Okay, and now I need this 2 to have the same kind, and I would say 3. I have this. And there, 3 and 3 complete the figure. Okay, so I have this nice figure now. And so we need to find the relation to this angle, to that angle. And if we look, we have this triangle is 180. The big triangle is 180. And if I do 180 minus this, I'm left with the 3 and 3 that is. And if I do this big one minus this 2 this 2 there, I would get this, and this. So this angle is equal to this plus this plus. So this angle is twice this angle. This angle is this plus this. And we said that this minus 2. So equal to all of this. And so that shows the relation. And from that, we can go back here. And we can also, no, sorry, we have to show something else. Is that if I move this point, I have another angle here, but by the same theorem, this angle should be equals to this one. So all these angles are the equals to each other because they are all half of this. They have to be equal. So we showed two theorems, and from that we go back here, and yeah, it's a bit difficult to see like this, but if we add some constriction, it makes it a bit more trivial. So that's what we should do. Oop. Up, I will do, and I will put dashes. And I would do the same. So I have this one and this one. So what we see that there is that this angle is the same as this one because they intercept this this chord. So they are these two angles are the same. These two angles they are the same, but because they intercept this chord. So if this and this angle are the same as this and this angle, then these two triangles are in proportion. So this over this equal this over this. And when you arrange stuff around, then you get that for that times that equals that. And that's the theorem that is proven. The nice thing with this theorem is that you visit two others theorem. Okay, now we can see other things. Like I can change to Skeuo homomorphism, new theme. Interesting. Okay. Yep. I can delete all of this and we can play with other stuff. If I create a bunch of points, like segments, a circle, for example, just to have some object, I can use the label tool, and if I click, it will set a label automatically, and it's aware of the type of object. So it will try to use small and big letter. Another thing is that if I remove like this D and this D, if I put a new points, 2 new points, and I label them, it knows that it has to reuse the letters. You will not run out of letters unless you have more than 26 of the objects. So that's nice. It supports LaTeX, so you can write any stuff you want, and there are already formula for you, and yeah, you just have to complete like you want. I mean, not sure if not doesn't. Okay, so you have the X like this, and you have the instant preview, and then you can move your equation around. So that's how I showed. Okay, then there is the ruler. We saw the ruler. Then there is the square. For the square, the best is to demonstrate by having a line, and now I can use. So you see that the square is snapping like the rest of the tools. And if you put your cursor on this semicircle, you can rotate it. And here you see that it snaps to the red dot, and the red dot is not random. Here it says 15, 30, etc. because I have the angle snapping set to 15. But if I say, for example, 60, it is not there, but I could use this and input 16. If I do that, now it will snap on the 16 angle, and it will just snap. We can also flip it, and for that we have to double click here or click option, and there is the flip option. Now you see that the degrees go the other way around, so they go counterclockwise. That's quite useful because if I flip, I can do 60 like this, and the angle here, if I draw it, it's 60. So yeah, that's one way to use it. There is a symmetry mode. The symmetry mode is useful because when you want to, and that's something you can't do on ActivInspire. That's why this tool exists out of frustration. So if I do like a small, and I want to make a symmetry of it with ActivInspire, if you are not in the ideal condition because the instruments are snapped, it's impossible to do. You can do it, but it will be ugly because it's not done for that. I would check symmetry, and now you see that when I move my cursor, there is the symmetric point that is also highlighted, and I would say that I want to snap to angle of 90 degrees. That means I can now rotate this. Okay, it's best to snap it to the line first. I can rotate this, and it will snap to the 90 degree. And it will slide nicely on the line. And if it goes astray, it's not a big deal. Snap it back. If I want more precision, I can say 20 here. It's not more precision, but it's more snapping. And then, yeah, it's snap from further away. So it's harder to slip from the line. And now we want to put our set. Yeah, okay. That would be for next version because I need, when I do slide like that, it also need to snap to the point. That would help. So now I can just click to add a point. Here I don't have the precise snap implemented. But the idea would be that normally when you move like that, close to a point, it should not there yet. Okay, and then you have this. You can take it. And so if I do like rotate like this and it's too short, it's already snapped. And I'm just bring them there. And we have the symmetry. Yeah, so that's using the square. A better way to do that obviously, and that would be infinitely more precise. Yeah, can I just, because otherwise I would do a mess. Is to take the compass, set the pencil on the point, draw an arc big enough, lift the compass, set thing here, draw another arc, and this point is one of the first points, and then you continue that way. So I will pick this one for example. We don't care about. The only thing that counts is and then it's because I have. And then the last thing. And we put a point here. And now we have to look at the points. So one with one, we have to. And then it's this one, word one. And then we need to finish that. You see that even with the compass, it's already, it's faster when you know, and it's more precise. So we have this, and if I move this, that's another bonus, is that the construction is, maybe it's not, it's semicircle. This one, I would put, I could put it. I also have to learn to. Okay, so now it's more visual and you can just move. And because you did the construction, the system knows what to do with that. So, yeah, behind the scene, it's circular. So. Alright, so that's nice. And you can also, because often we show that this one is the bisector. So you could decide to just draw the bisectors. And there, the nice thing is that the ruler is already correctly placed. The rotation is already correct. So it's even faster too. And you would set a nice times to change to Win98. And then you see that they are dashed. And then you can also add a point and say, okay, this, and this, we don't get any point would do. It's actually a right angle. And you could repeat to mark all the right angles. And it's still, it would still update. And you see at the bottom, there is a button that says page 1. If you double click it, you can say symmetry, for example. And then you could do a new page and do whatever you want on the new page. Take some note, put an equation, and then go back to the first page and flip between pages if you need. Let's jump to the Aqua theme. So you can have multiple pages. You can obviously save and load. So and then, because often you prepare some canvases and then you fill in bit during the lesson, so you need this ability to import. And you can then have multiple page. There is no limit, only memory limit. Did we see everything? Auto keys, snap. Yeah, there is a grid snap, but it's not very important. And there is a unit snap. That's stupid, but that's a good one. So if I have this ruler, and you see the ruler follow the theme, you see that it's not very precise because it's half units only. So yeah, if I want to do 6, it's nice. But if I want to do 2.2, it's impossible. Either 2 and 2.12. So for that, I would go here and I say 1/5 or 1/10. So 2 is something like 1.2, the 2 this a fifth. And yeah, you can be the millimeter, so there I have now the precision. And you see that now that the magnifier is really helping her because you would have to squint to read the roller, and if you are far back, yeah, it would be impossible. So the magnifier shows you. And to show that it's accurate, we can do the simple Pythagorean triplets. For that, I would need 3 units. I would do 3, and I would need 4, and then I would need 5. So these are the 3 things. Would take my compass, and I would use this span and just circle. Yeah, but I would reuse the segment. I need point. Or, okay, let's be not stupid. We will start from a point, and then, yeah, that makes sense. Yeah, that makes sense. So I do my and now I need to use that one and that one. Put in the top here. And the snap is helping a bit. So I have this big one, and then I would put here, and I would need to, and I would, and there you see that we have an intersection point. Yeah. The last one should be 5, but I think I fucked up, yeah, because it's late. Let's do it properly. I will just reuse that one, and I confused. Okay, so this back to use that. And this one. And that way there is less noise. And that means I would need to connect this and like this. And there we see that says 5. So that shows the precision. And now we have this angle, so we know it's 90. So if and I can ask them maybe I didn't saw it. Okay. Okay. So if I choose that, I can scroll and I can say show amplitude. And it says 90 because it has to be 90. It shows that the construction is very precise. Angle is not 90.00. Yeah, and then there are the images, but I don't want to show files. But just to insert images. You can also change the scale of the cursor. Sometimes you are on a board where the cursor would be very small. Yeah, and the grid snap can still show it quickly. It will just snap the point to the that it doesn't want to do it. The unit size is also dictating the separation, the distance between ticks. That's something I did on verified color. We see that ticks are so yeah, I can augment the number. Ah, is it because that no? Let's reload. Maybe that's there was something. Oh yeah, that's the grid snap. The cursor is now snapping correctly. And if I make the grid bigger, the jumps are simply bigger. And you can see that the tool is also snapping. So that yeah, what snap is where the cursor. So that allows to create shapes that have all the vertices on the grid. Sometimes it's required, but it's bigger. In primary school, it's the case. Things are aligned on it. And you see, even the tangent here, we noticed it's it shows intersection. And if I move, yeah, it has to choose one of the points. Yeah, it doesn't put all the points. Yeah, let's switch to another theme. There's a Playful, it's for kids, but everything is colorful. And then there is a dark is dark screens. You can change the point color to make them pop. And the colors, they are paletted according to styles. If I go to classic, it's change the colors. And yeah, that's it for the presentation.